Okay. I got to get my Discord open. I got to go get tea. All these things. Okay, so for people showing up right now, we're gonna give people time to show up. We'll probably start the official discussion at like 10 minutes after, just like in college or whatever. Put that in real big so people could see it. Oh, there we go. There we go. Look at that. All right. Yeah, the Twitch notification, maybe they actually started getting them out faster. I don't know what the deal is with that. Yeah, so this is going to be a more focused discussion, and well, I'll give an official intro when we get to that part. Oh yeah, I bet I'm really big, huh? Sorry. Good point. I forgot that I had made myself real big, like Kanye the Giant. Because I was demoing lockpicking for someone and I wanted to record a video. Do you want to see my lockpicking video before we start? Here, let's do that. This is just something I emailed to a couple friends. I think it's this one. Is it really only 24 seconds long? Here, let me make sure this isn't porn of some kind. That's the wrong video. Oh, because I moved it. That was, okay. That was when I was getting the camera to work. So it's here. It is here. All right. Here's a fun lockpicking experience that I had last night. While I get my tea. Okay, so this is a set of Master Lock firearm trigger locks that I just bought. And off the Lockpicking Lawyer's website, I got a basic lockpick set that I really have no idea how to use and certainly no skill at. But here's one of these locks. The camera's not really focusing very well. And it is locked. I can't separate the two halves. And so I was like, well, I'll just start feeling around in the lock, and I probably won't be able to pick it because I've never done this before, but let me just try to feel it out. And this thing was laughably easy to pick. I just kind of went in and jiggled around a little bit. And look, it came right open. So I dropped the little wrench. So I could just rotate it back, right? So now it's locked again. Pieces won't come apart. Okay, so it's locked. I can't turn it, and I'll just try to pick it again, right? Oh, it's taking longer this time. Oh, there we go. You just have to hit the right spot. Boom. So high security for dangerous applications. See, this is a variety stream. You get variety on this channel. Is it a one pin lock? No, it's supposed to be. This is the key for it, and it looks like, I guess, 4 or maybe 5 pins. I don't know, but in practice, it feels like 1 pin, or maybe 2. Like, it feels really silly. Yeah, Master Lock is kind of the joke on the Lockpicking Lawyer video channel, which is actually kind of why I bought Master Locks there, because I wanted to see if I could pick them, because I bought them for California compliance reasons, right? And then what happens if I lose the key? Well, if I know that I can pick the lock, then it's not bad if I lose the key. Yeah, I saw the gun lock picked with a twig video. Actually, if you guys have seen, this is the best one. I don't want to show it on stream right now, but maybe we'll do it at some time. If you want to get red-pilled about locks, go to YouTube and watch the following video called, Inexcusable Police Car Gun Lock Bypassed in 1 second. Watch that video and think about how many police cars have this lock in them. and you'll know about locks. I'm looking tanned. Yeah, I was in Miami for a bit. All right, we're going to start soon. 4 minutes. Is it the magnet one? Yeah, it is the magnet one. Still planning on the Miami move. I have never been planning on the Miami move, but it's a decent possibility. Like I could definitely live there for at least a year. So it depends. I need to talk to some CPAs about whether it makes sense to stay in California or not, basically. All right, it's about 3 minutes. We'll start. I should get a chocolate bar. I should stage a chocolate bar. Let me make sure. Okay. Yeah, we're going to have a stream. He sure doesn't do a lot of lawyering on his channel. Well, he does pick a lock that gives you legal advice at one point. Shaders would be much easier if you could debug them. I mean, the thing that you do in a game engine is you make provisions for different view modes. So you make view modes like normals only and diffuse texture only and stuff, and you like pass that enum to the shader, and then the shader like does those things, and that at least lets you, for a complex scene, it lets you see stuff. But yeah, still at some point you're resorting to 101, you know. Okay. Yeah, you don't seem to be able to step through them with anything I know of. Like there's stuff like RenderDoc and Nsight, I guess, is the NVIDIA one that I never use. But like, there's a way in which things really went backwards. So back, I'll go on a couple-minute diversion before we start the actual stream. Like back when I was doing stuff on the PlayStation 3, where you uploaded programs to the SPUs in a way that's not really that different from what happens with GPUs today, where you upload shaders to them, right? You would upload your program to the SPU. You probably had to have some data structure in common that allowed you to transfer data from your main program to the SPU, right? And let the SPU program decode it, very much like shaders. But they were programmed in the same language that you used, usually C++. If it was simple C++, you could just compile it for the SPU, right? And so I would just write my code so that it ran on the CPU, right? And then I would have an if-def around it of like, either compile this for the CPU or for the shader. So I would just develop on, or for the SPU. So I would develop on the CPU, right? And then move it over later after I had something that was kind of working. And then if I needed to debug, then maybe I would work on that directly on the SPU for a while because that runs a lot faster. But then if I ever had something that was hard to debug, I could switch it back. That's very powerful. And for some reason, we've dug ourselves such a deep hole with shaders that you can't do that anymore. In fact, I'm actually going to put that here. Like, what if you just had a software pipeline that used the same API and you just could switch back and forth? I mean, Direct3D had that for a while with like the reference implementation, but it never was quite that easy to do this with, in part because I don't think you could really step into that either. Maybe you could. It was just always way too heavyweight and gross, but like why don't we just let you do that? Doesn't Visual Studio have an HLSL debugger? I never got it to work when I was trying to debug shaders. And even if you could somehow get it to work, there's like increased friction in trying to do that debugging. So like, why? Like, okay, I think we should get started with the official thing. Boom. All right. Thank you, everybody, for coming by. This is going to be a discussion where the first part of it is primarily with the existing beta users for this programming language. And so I'm going to be ignoring Twitch chat for a while, and I'm just going to be doing chat in the Discord channel. And even before we do chat in the Discord channel, I'm going to start with just a straight up like spiel, like here's what notes are in the language and how they work. Because some of the beta users, even who may be pretty experienced at certain aspects of the language, may not have used notes that much and don't know the issues. And so I'm just going to set context for discussion. Then I'm going to do maybe some back and forth with chat in the Discord directly, because those are the people who have the most experience using the programming language. And then eventually, after that's done, we'll go back to Twitch chat and we'll do Q&A with Twitch chat. That seemed to be a good format last time we did this a few months ago. So that's where we're at. If you're in Twitch chat, just sit tight. We'll get to you eventually. Yeah. All right. So flip over here. And for people in the Discord, I just typed this, but we're doing the chat. It's in the questions channel on the secret Discord. And I'm just going to do the intro spiel first. And after that, we can go into Q&A. All right, so notes were added to this programming language a long time ago, and they were added to directly solve certain problems that I had with C++, right? Which had to do with, marking up members on structs usually, right? So in a game or something, you have a struct. Let's go to an example right now so you know what we're talking about. So I'm going to go to the Sokoban game, and we have all these entities, declarations. Let me find one that, so this is one, everything with the @ sign on it is a note. And what we're using these notes to do here is version management of the members of the entity, right? Because, okay, so this operates in concert with another feature, which is the runtime type information, right? So in the games that we did in C++, you would declare a struct, but because you can't really introspect on that struct in C++, I mean, I guess they're going to add a bad version of that eventually, but especially back when we were shipping Braid and the Witness, you couldn't do that. Then if you wanted to integrate your struct with an editor or with in-game serialization and loading or something like that, then you had to somehow explicitly write code that knew about all the members of the struct. You could try and do something that parses the header files and generates code, but that's really ugly in that kind of language, and it adds an extra build step that always goes wrong. And I had very bad experiences trying to use systems like that earlier in my career, so I did not like it. So what we did was we said you can put little tags on the runtime type information. So, you know, when you do a declaration like this, you put a little @ sign tag and you put a thing, right? And this thing after the @ sign is actually just a string. It parses everything up until it hits a white space, and it just puts all of this into a string. So there'd be a string that says v4-7 in a note structure that in a little bit I'll show you where that lives, right? And then this do not display is another note, and no serialize is another note. And, you know, this works fine. Like, we've been using this for years now in several programs, but especially our commercial quality game that we are going to ship. Yes. Somebody added these, but they didn't actually know the semantics, because like no serialize doesn't actually operate with versions. No serialize means ignore the versions. But that's also, you know, people come on the team and they don't know, and then they do stuff and it kind of works. Actually, I think I added those members. Or no, I didn't. I think someone else did. Anyway, whatever. Just doesn't matter. So the point being, at runtime, we parse these, and I don't remember. Okay, here we go. We have parse version note, and basically at runtime you look up a struct and you pass the note in, and we have a thing where we say like, okay, does it start with a number? And if so, look for a dash, right? And so forth. Or actually, you know, does it start with the letter V is probably somewhere. But basically you write this kind of parsing code yourself, which is not like, I think people freak out about parsing for some reason and think it's hard. It's really not that hard. It's not that hard to do robustly and securely if you're not in a language like C. Like, the problem is C, anytime you play with strings, is potentially dangerous because they're not bounded, because you just have a pointer to memory with no indicator of what the length is. But if your primitive is actually an array or a string that has a length on it like it does in this language, then all your operations can be bounds checked and are by default in a debug build. And so it's very easy to catch that kind of a bug. And so, like, I think people have a weird view about parsing. They think it's harder than it is based on experience that they have in languages that made it harder. Anyway, it's not that hard to do, but you do like have to do it first of all, right? And you could imagine having more complex notes than the ones that we just looked at, and that would require more complex parsing. And you just have to, somebody has to write that code. This isn't that much code, but it's significant. And oh, this is just for that one. Let's look at where this is called. So if it starts with V, we call this, right? Or we have these other things that we recognize, and we just have if statements for each one, right? Actually, these are not. I'm just cleaning up the code today. Okay. So oh, and then here's one. Let's look for an example of that one, the page note. Nobody uses that right now, at least nobody in this file. What page was for is like, hey, in the editor, we have a user interface where there's different tabs, and sometimes you want to organize things by tabs, and maybe you want to reorder them later, but you don't want to move them in the struct because the serialization expects them to be in a certain order. You could like override what page it would be on by default. But I probably put this in a long time ago and then just never had the need to use it yet. Anyway, so that's what this kind of code looks like. It's a lot less work. I don't know what I mean by cleanup semicolon. That's a really old. That's a really old note. None of that matters. I think we cleaned up that and didn't delete the comments. Okay. So that's what it looks like when you use this kind of thing at runtime. Let's look at one other example of how this is used. Not actually on data structures, but on procedures now. So if I go into commands, so we have, let me just show this off. Actually, we're going to run the debug version of the game. Maybe I should have run the release version. It would start up faster. Anyway, this is a level that doesn't look like much. It's very, very basic. We have this in-game console that you can pull over, and you have commands. So I could say help to see what all the commands are, and there's like a lot of them. And, you know, this actually includes the editor commands. You know, I can run any of these, and some of them do quite a lot of work. I'll go into the editor here. It's taking a second to load. Okay. Or even we could go here, and I could go who strings warrior. This is just a console command that our own system is handling. Nobody really. What is it called? It's supposed to look at these guys. Oh, you know what? This isn't okay. No, this command is old. See, this is what happens when you try to demo things. These things used to be string properties, but now they're pointers to meshes, and like our whostrings command only looks at things that are strictly strings. So like, I don't even know if we have that many strings that are strictly strings. Let's try a different command that's not old. Okay, so we have this merge command, for example. Like, if I could make all these, you know, different things here, and I could make them different colors, you know, and they're different entities, and I can move them separately and all that, right? But at some point when you're building something, maybe you put these together and you want them to all be one now. For the purposes of convenience, I can use this command called merge. And when I do that, you'll see the colors change because there's only one color per, you know, wall set. But there we go. Now it's one wall set, right? And I can, you know, undo that and whatever. So that's an example of a command. If we look in the program, we can see where that is. That's in editor commands. So, and the question is, how does it know? How does it know that this is a command that you can run from the console? And the answer is, it sees this register command note that's after the declaration, and the metaprogram at compile time looks at all the procedures that come through, and it says, hey, are there command notes on any of them? And if there are, then we put this in there. And actually, there are multiple notes. There is like an editor command, I think. Let's go look at the meta program. So these are the different things that you could tag procedures with. And as messages come through while we're compiling, we look at however they're labeled. We have like key map handling routines. So these are things that that would have been a better thing to demo probably, but let's go look at a key map. Like here's our gameplay key map where you can say what key is bound to what function. And then how do you know what these functions do? Well, those are registered from the program by being tagged with this thing, gameplay key map. And that's all you have to do. Let's find those. Right? So unlike C++, where you have to do a bunch of grungy work, here you just say, I have got this function called restart, and I tag it gameplay key map. And doing this lets you then notice, or lets you then export this name restart to be usable from this file, and that's all you have to do. That's literally it. And then at compile time, it'll make that binding. And of course, we made some code that does the binding and that actually in the cases of commands, it's a little more complex, but even here you can see that some of these are functions that take bool and some of them aren't, right? So the ones that don't take a bool are just you press the key and it happens. And the ones that do take a bool are more like if you hold the key, it's true. And if you release the key, it's false. And the meta program looks at the type of the function to determine which one it is and generates the correct binding code, right? And so you end up in this routine where there is code that you have to write, but it's the code that you actually want to write to do the actual functionality that you want to implement, right? All the grungy background work of just like somehow having to manually register all this stuff is no longer necessary, right? Okay. So we've been using notes that way for a long time. Is there anything, let me ask in the Discord, is there anything confusing? We don't want to go to general questions yet, but let me know if there's anything confusing about what I said. This is not a super premeditated discussion. It's not like an hour-long speech that's been prepared for days, but hopefully the idea is getting across. So the next step, that's just background of how these are used and what they look like. And the next step will be to talk about a little more specifics about the way you look at these at runtime. I said runtime a few times and people in Twitch were unsure if I meant that or compile time. Okay, we'll talk about that next. So I think we'll clarify that in a minute. Okay, a couple people in Discord seem to be following along. I actually can't tell who's live in the channel right now, but I assume it's a reasonable number of people. Okay. There's at least 6 people live in the channel. 7. Okay. So 8. Ooh. So there are 2 different times that are significantly different that you can look at notes. There's a compile time way that you look at notes and a runtime time that you look at notes. And we've actually looked at both of them. So these key map and console command stuff that we were looking at happens at compile time because in response to these notes, we generate code. So if I go back to the meta program, when we see these notes about commands or key maps or anything, we put these in arrays, right? And then when we're done compiling, we call this function generate code for commands, and it just goes over all these arrays and it calls some functions that does this. So like if I go look at key map line, this actually So this is like checking the function signature, I think, to make sure it's one of the ones that we want. And then we say add key map proc. Oh, and I guess, okay. So I said before, what I said was a little bit of a fib. I said that we check the type of the function at compile time to see which kind it is. I don't think that's actually true. I think we have two overloads of add key map proc. And one of them takes a function with no arguments, and one of them takes a function that takes bool. Let me see. Yes. Okay. So let's go look at that directly. But so we have an add key map proc that takes a key press proc and one that takes a key toggle proc, right? And those are just, you know, and so, and then the only difference is we set press proc versus toggle proc on this info struct, right? So key press proc is a function with no arguments, and toggle proc is a function that takes bool, right? So if you tag something that's not either of these, you'll actually get a compile time error generated by the compiler here that might be a little bit less user-friendly than you wanted to. Like if we check the type here, we could give you a much more customized error message, because the compiler doesn't know that this came from you tagging a thing with a note, but our code does. So we could check it and say, hey, this isn't a valid key map proc, but we don't do that right now because we're lazy. Specifically, I am lazy because I wrote this. Anyway, so this is just code that we're generating. So this is like a printf style function. And we're just like doing a printf where we put things in the parentheses to like make this code. And then is it in source? Really? Aha, probably workspace 3 these days. Okay, so here we go. We just make a giant dumb function that looks like this, right? And in the C++ days, we would have had to make this by hand and keep it maintained and all that. But here we just auto-generate it every time we compile. It looks really stupid, but that's quite fine. It's actually preferable than to do something more structured and complicated, because if you want to debug this or see what's going on, you can just step through this and it's really obvious what's happening, right? So this added strings file is just something that gets generated every time you compile. And you know, all these strings that we synthesize just go in here, right? So in our meta program, when we say generate code for commands, it makes this, right? Well, and it makes actually all these things, right? So these are our key maps. These are our commands that are callable from the console. These front command things are things that actually parse arguments. So you could have a runtime argument parser or a compile time argument parser, and we decided to do it at compile time. So we take an array of strings on all of these, right? So it's like a common interface, but then we do whatever parsing is necessary for those strings, and then we call the thing that's actually in the code, which is strongly typed, right? And so that's how we get generalized type checking on this. It's like we have an interface between a weakly typed thing, which is the strings that you type in for the command, and a strongly typed thing, which is the actual commands in the game. So let me pick something that looks complex here. I want something that takes multiple types. Okay, so this is float and bool and all that. So this saves out OBJ files, which is like a mesh format. So this thing you can see, it has a string argument, float argument and all that. And you can just call this. This is just a regular function that you can call from elsewhere in your program, and it's strongly typed. So you get all the benefits of a strongly typed programming language. But our compile time code generator generates like this weakly typed interface to the strongly typed thing, right? Now this whole thing about arguments.count as 0, 1, 2, 3, or 4, this is a really lazy thing that I did because I didn't want to parse the signature of the function and look at default values for optional arguments and then put them like the thing to do if you only wanted one call for this is to assign whatever these default values are, to assign those up here and then only override them if you get strings for them. And then you would only have one call. But like I didn't want to do the unpacking for all these data types, but we probably should, because then we can provide that as a library that everybody could use. Anyway, okay, so this all happens at compile time because it generates code, right? And you can't generate code at runtime because it's a compile time type checked programming language. We don't like JIT at runtime and stuff. Although if you link the compiler as a library, which you'll be able to do in the future, you probably could do that. It's just not, it's not a thing that we recommend because strongly typed programming languages are very, very powerful. However, this thing that we did before, this stuff, this is runtime. Why is it runtime? We could also parse these notes at compile time and do stuff, but sometimes it's just easier to do things at runtime if you can. So for all these notes, all we really want to do is make a little data structure for serialization and maybe a little bit for the editor interface that says, hey, when you're loading a camera control, this member bloom intensity old is only valid from version 9 to 10. So if you're version 12, don't try to load this, right? And that can be a runtime data structure and it's fine. There's no real speed work. Well, I mean, for the shipping version of the game, it's unclear because when you ship the game, you probably should know what versions all your entities are, so you can like clear out all the old versions, and you wouldn't usually take any of these if statements. So branches that are 100% predictable or probably don't really cost anything usually. However, you know, when you patch the game and stuff, you might need to add entity members. And so you would leave the code in and we would make that judgment call. A thing that we could do late in development is change this to compile time code, right? That would then bake out a very hard-coded load this entity type function that might run faster. But for now, I made the decision that I preferred the flexibility of it running at runtime, right? So now let's talk about this information. How do you see this information? Well, the runtime information, you get in type info. And so you have this primitive called type info in the language. You can say type info of any type. Types can be used as first class values the way they can in classic functional-ish languages like Lisp and Scheme and whatever. You can just use a type as a value. And so you could say type info of one of those, and you'll get, if it's an integer, you'll get a type info integer. If it's a string, you'll get a type info string. We covered that extensively in prior videos, so we won't really go into it now. This is just a thing, you do this all the time in this language. It's very useful, right? This is what you wish RTTI had been in C++ originally, but they didn't do anything good for RTTI. Okay, so let's go to structs. When you have a struct, the type info for that struct tells you what the members are. And for each member, you get this struct member. And this is actually where we export notes on runtime data structures. And it's really the only place, at least classically, prior to this year, this was the only place you could get notes at runtime. And that's because this was designed for a very specific use case of doing this thing, right? It's like, okay, we just put the notes here. They're available in this structure. All of this type info, the reason it could be used at runtime is because we export a data segment into your executable that contains all this type information if you want it. You can turn it off, right? But then when you do these type infos, it'll return null and you'll be sad if you try to use them. Actually, we generate a compile time error. But there might be, like, if you call some function in a library that expects to have that or something, you might, I guess, run into trouble. Who knows? Anyway, this works because of data that's packed into your executable. And so we pack those notes. The compiler at compile time serializes all the notes and put them in there, and it's just an array of strings, right? Now at compile time, you actually can see more notes than you can see at runtime, because here you only see, again, these struct members, and you can only see information about types. But at compile time, you can see the entire syntax tree of the program. We have this thing called code node, which is like the base class of the syntax tree. It has all of these members in it. And so if you have like a procedure call in your program, and you can just look at the syntax tree for the function, and you can see who it calls, right? Or if it's got a return statement or a while loop or a for loop, you get all these data structures and you can look at them. And where notes go here is on declaration. So here we have an array of notes. And if you're a beta user, we have some demos and example programs that look at these as well, like in the how-to, as well as I think in the examples folder. Now, at compile time, you can see both these type infos. You have two ways to get at the same notes at compile time, because you have the type info available, so you can look at the same stuff that runtime can see. But you also have this code struct, which has a block. The block has statements. Some of those statements will be declarations, and those declarations will have notes on them. So this is an important thing that we'll get into when we ask about how to expand notes, which is just the solution that I came to for a while was we're mostly going to put notes on declarations, and that should be good enough to both tag procedures and tag member declarations and do a few other things, and we'll figure it out later if we want more general handling. And the thing is, just now it's later, right? Now it's more like, well, let's figure out the next step, if there is a next step, or maybe it's a small refinement of what we have, maybe it's a big refinement, right? So there's actually one other place that you can put notes. You'll notice, like, struct has a notes array on it, and that is because structs aren't always attached to declarations. They usually are. Like, especially if you come from a C or C++ background, you're going to feel very comfortable doing a struct like this. But structs are actually first class values, right? So I could write a program So I'm just going to make a little function here. I'm going to say a thing is a struct with name is hello sailor, right? And value is, no, that's not a good value. Everyone knows the right value is 69,105. So if I say, for example, let's just do it a classic way, like you would in C or C++. I could just say T is a thing, and I can say F of T. Let's call it, because we have a T here, a capital T. Let's say A is a thing, right? Okay, so I'm going to go compile my program. Okay, and so X is basically the default values of this struct. There's nothing really surprising there. This, I said $T here because, hey, I want to be able to pass anything. Why? Because you can actually do the following thing. You could say f of struct right? Now this actually has a different meaning. Hopefully that'll parse. There might be weird stuff about it. No, that's fine. Now this is actually different though. This doesn't mean the same thing because what we're passing in here is the type, right? This isn't an instance of this type. This is the actual type. So you can pass this to f, but in this case, x will actually be the type of this anonymous structure, and t will be of type, right? So if we run this now, x is anonymous struct, t is type, right? If you wanted to instance that, let's make another function. Right? I could actually say, okay, sorry, an instance of x, we're going to say x has to be known at compile time, and we're going to say instance is an instance of x. All right. So when we do that, so t is type, right? Just like it was for f, but an instance of x is 42, right? And so this is a way that you could very fluidly use types as values and whatever. It's just, there are some, like if you're going to instantiate a value of a type that was passed as a parameter, because this is a strongly typed compiled programming language, that value has to be known at compile time. And that is why we put the $sign here. Of course, you could also get, like if you needed to know this, but you needed to get it from a function or something, you could run that function at compile time, which is where the power of compile time execution comes in, right? Okay, so that is why we made this allowance for notes being on structs, because you might want to put a note here like hello sailor, right? Actually, let's, because we had this string hello sailor, let's say Gondar, right? Let's put a capital G. Rezrov, right? Okay, so we can actually look at these notes, even though this is an anonymous struct, not bound to a declaration, right? So I could say info is type info of x for info.notes, print note, whatever it, right? Hopefully that's right. Notes is not, it's not. Oh, because this is the type info. Okay. Yeah. So these notes, okay, this is where there's a little bit of an inconsistency. The notes on the struct don't get exported to runtime in the type info. Let's try something here, though. This is shooting from the hip here, though. But we could get at them at compile. The normal way, okay, the normal way prior to this year that you would get at those notes is you have a compile time meta program that runs outside your main program and looks at the declarations coming through. That's what like that command processing that we showed earlier would do. Starting this year, or maybe late last year, but I think this year, you can actually get this kind of information from inside the same program, right? Because the compiler does this nonlinear compilation where dependencies are satisfied, and it means that you could do things that you couldn't necessarily do before. Now, I haven't tried this specific thing, so this is like scary, and we could run into like, you know, demo crashes from immature features or something. But if instead of doing the type info version, if I say, how do I do this? I feel like I have to do something a little bit extra stupid. Let's just say, this is interesting because if I have to do something really weird here to get at this information, then maybe that informs. We're entering the part of the presentation where it's like, let's start thinking about what this should be like. Like what I'm thinking right now is like, I could say, I want to get the syntax tree for this struct from within the program itself. From the meta program, it's very easy, but from within the program, I'm thinking like, I want to say something like nodes is compiler get nodes of some code. Let me show you. We have this thing called compiler get nodes that you would often use from inside a macro or something, right? And you pass the code and you get this stuff. Now, I don't think I can pass X right now. I don't think that implicitly casts. Oh, we have to import compiler. Oh, it does. Okay. Let's just see. So this return value from compiler get nodes is a code node, right? And so we looked at that before, and it's got all these members, right? I should call it node instead of nodes, right? There's another return value that's like an array of stuff, but we're ignoring that one. Let's just see what happens. Oh, this is running at compile time, of course. Sorry. Okay, so this has a bunch of members. We could actually maybe draw this in long form if we cared, but so it's an identifier. See, I got the code for the identifier, which is what I was scared of. I don't want the identifier. I actually want to evaluate this to a struct. So like if I do something stupid like that, yeah, it's just casting whatever I put in here to code. Like, so this is a little bit of a weird singularity where it's like, like, how do I get from within the program, how do I get this without writing a meta program on the outside? Does anyone in chat or in Discord know? Has anyone done this? Yeah, okay, so someone is asking about type info. When I did this thing, originally, when we made the original YouTube demos about type info a long time ago, it always returned the base type. But I realized the more strongly typed, better thing to do would be to return the most specific type for any situation. So if you take type info of a struct, it returns a type info struct, which will implicit cast down to a regular type info if you assign it to a regular type info, right? So you don't necessarily have to care if it's a type info struct if you don't want to, but if you do want to, you can directly use it and it's much more convenient. Okay. So this is one of these awkwardnesses where like all of the power in the compiler to do this thing that I'm trying to do is there, but I can't quite, like there probably is a way to get at these notes right now from inside the program, but I'm not quite sure what to do, right? If I did the following thing, right? Let me just comment this out for a second. If I just say code right there, oh, well then we can't say this because it's a code, right? Actually, I mean, I guess I could do that. Yeah. So if I just say this is a code, whoops. Oh, because I got rid of T. Let's just do this. This is more like what you would do from a macro. So now that this is a code, I probably can just like insert it or something, right? Or just say compiler get nodes from it, right? And then do this. So now I have the actual struct here, right? So now, okay, so I could say, because I know that's a struct, so I could say assert node.kind is struct, and then struct is cast code struct node, and then for code struct dot notes print whatever it index and it. Okay, so I guess those are, oh, these are, okay. This is the other difference where, because this is a syntax tree, instead of pointing to the string directly like we do at runtime, these are code note pointers. Whoops, it was right there down here. And then it.text, right? But the interesting thing about that, okay, so there we finally got to the note. We have Gondar and Rezrov, right? But this is weird. And I couldn't just pass the struct by value like I wanted to. I had to put code in front of it. Maybe there was a way that I wasn't thinking of to not need to do this. But if it's not that obvious to me right now, it's definitely not obvious to most people, right? Like, I know this language better than anyone. And if it takes me a little bit to figure it out, yeah. So basically we have this feature that was made for very specific use cases that now that other powerful parts of the language have come online, we want them to integrate better, right, is the point. Like I said, it's actually very easy to get at these notes from the exterior metaprogram if you have one of those. And a large project like a commercial video game is very likely to have an external metaprogram like that because it's very useful. But a small program, if you're just sitting around like, hey, I just want to write something cool today, probably doesn't have one of those because that's like more like a larger piece of infrastructure that you would put into play. So, you know, we want to give people the ability to easily do things from anywhere. So you want to be able to do this more easily, I would say. But also recall what I was saying 10 minutes ago about like notes normally go on declarations, but then there's also this weird place where you could put them here. But like there's no equivalent place for like an enum, right? There's the enum statement and that doesn't have notes. And like this is really sort of a one-off special kind of a hack. So the question is, where do notes go? Like maybe they should be able to go anywhere in your program, right? So maybe if you just have a function and you have a bunch of statements and a note could be in the middle of the statements, right? Now the upside of that is you would be able to see that with a metaprogram normally. The downside is a statement in the middle of your program isn't going to go into type information, right? Because all this syntax tree stuff does not get exported into your final program, and it's unlikely to because it would be a lot of data and we don't want to bloat your executable, but also like it would be very easy to disassemble your executable, and a lot of people don't want that, right? You could make a user level library that serializes all these so that you can get at them at runtime, and I assume someone will do that if we don't do it. But as it stands right now, by default, it's not a very easy thing to do. So people, I doubt that anybody has done this yet. Now we could put notes just anywhere in statements. That's still not really everywhere that you would want to put them though. So like if I just have like factorial, right? Right, return, right? If you went to functional language school, this is how you think you write factorial. And it scars me from going to Berkeley that this is still the default way I write it, even though iterative is better. So like, what if you just wanted to say x is factorial of 5, but I wanted to put a note on the argument or something, right? That's not something that you can do right now. Like the parser doesn't let you do it. Even if the parser let you do it though, you have these questions about, well, your metaprogram is going to be looking through the program. And if there's notes in weird places, maybe it can get confused, right? Or maybe we end up making the job harder for the user to understand the program if there's notes in all sorts of random places, right? If there's a potential pointer for notes on any random, okay. So like, I don't know, imagine this was a function with 3 arguments, right? Not factorial anymore. And we have notes on 2 of them. Then it's like, does this note slot go on the code procedure call, right? So we have these arguments, and that has a code argument struct, and maybe we say there's a note here. That bloats the size of code argument. And if you just want to look through a program for all the notes, maybe if every data structure has these, so like if enum member has these, and you know, like binary operator has this, like if you could say y is 7 plus 15, and that's supposed to be on the 15, then, you know, code binary operator might have like left note, right note. Suddenly you've got notes everywhere. Your data structures become huge, and it becomes a pain in the ass for the program to figure out where these things are, because if your metaprogram has to try to make sense of this stuff and it's spread all over your program, your metaprogram suddenly becomes very complicated. And complicated metaprograms are honestly bad, because you don't want to fall down this deep hole of programs becoming infinitely more complicated. Like, part of our goal is to simplify things, and that's why early in development I didn't want to get carried away with this. So this is one dimension of this problem that I don't have an answer for yet, and that's why I wanted to throw this open to discussion, is just like, where do these go in your program, and how do you see them as a metaprogram user, and like look around at the program? How do we make that easy? And honestly, I haven't thought about it anymore than what I've said. I just wanted to like do this session before I think about it more, because I wanted to make sure that I wasn't like fixed in my thought patterns about what is good or what is possible. Now, another way that you could do notes is, instead of storing them on all the little data structures, you could have like per compilation unit. So like a function is a compilation unit, right? In this language. This is, so for people who are in the beta, when you get a, you know, a code type checked message, it has an array of declarations. Each declaration is attached to one compilation unit. So like this whole function would come through, or like a struct would come through, or whatever. And on that level, we could say, here's a mapping, a flat mapping of like note to expression. So we might be pointing into this syntax tree with various notes, right? And that would be much more compact, and it would be easier to browse. Like if you just want to look through notes, you don't have to recurse down into everything or whatever. You could just like look at this flat array, but then it might be harder to map that to places that your code goes, if your code does navigate recursively through the data structures, right? So that's a question, like, what is good there? Okay, so we're almost at an hour already, but that's fine, because I think the next part is short. So question number 1 is where notes go, and question number 2 is how notes are represented. Right now, the only kind of note is a string. right? And at compile time, you got this thing that looks more strongly typed, where you have the string and the note flags, but there are no note flags right now, I don't think. Note flags, and there's literally there's no declaration of what this is, and the reason is because it's always 0. This was like, we're probably going to want to make this more strongly typed eventually, and we never did yet. So, right now all notes are strings, and it occurs to me that they probably should be more strongly typed because this is a strongly typed programming language, and one of the problems that you could imagine happening with notes right now is in a large program, you might pick a form for notes that conflicts in some way with what like a library might pick, if you're using a math library or something. So for example, if we go back to this entities thing, we just, for the simplicity of our own program, we just said, look, anything starting with a lowercase v is a version note, and we're going to parse the rest of it, right? It's quite easy to imagine that you use some library that has notes that mean certain things on it, or a module, right? In the parlance of this language, you use some module and it's got notes, and maybe one of those notes starts with a lowercase v because it's just the word vector or something, whatever, right? And it doesn't mean the same thing that we chose to mean. So at that point, things start getting weird. You could say, okay, well, depending on what file the note's in, then it's either one or the other. But then you can't just call, like maybe that module is providing you a note handling function that you call with these things from your meta program, but then you have to filter things out of it. And is that always going to be possible? You could have situations of complete ambiguity. Like say I have my own program and I have a note called like vector, right? But then I have something else in the same file from some library and it has a note called vector or some other common technical or English word, right? But they're supposed to mean different things because we both chose different things, right? Now, when it comes to data types and all that, that's not that bad because we provide namespacing operations. So if two different modules want to declare things of type vector, then you just say, I don't know, like math is import math, right? And you just say misnamed CPP style ArrayLib is import ArrayLib, whatever. And each of these has a thing called vector, and you call one math.vector and another one, misnamed CPP style ArrayLib.vector, and you can just resolve that name conflict yourself. And if you want to call one of them the official vector, you could do this, right? So all this strong typing of the language and the namespacing properties handles that. Right? So it is really not an issue. And this is a problem that came up all the time. I have fond memories of porting my game engine to the Nintendo GameCube, and I had a struct called quaternion, and the Nintendo standard header that you had to include everywhere had a struct called quaternion. It was not fun, right? And C++ adds namespaces, but namespaces in C++ are broken and don't solve the problem because the person who created the namespace names the namespace. So you still have name conflicts, right? So in this language, we say, no, the user of the namespace creates the name of the namespace, and you can name it whatever you want. And you are free to resolve these name conflicts. For regular declaration, like regular values. That's not true for notes right now because notes are just strings. So you don't have any of this power, right? If I'm inside a meta program and you have a variable defined as one of these vectors, I don't just look at the name vector to see what it is if I'm being responsible. I could see where this data type is defined. Is it inside a module? Is it inside my main program, right? I can introspect on the whole struct where it's defined and make very strongly typed unambiguous decisions about what to do. We can't do that with notes right now. And so the question is, should you be able to do notes like this? if I say v is float, I don't know. I don't know why I would have a vector note on a float, but whatever. Let's just say 3 floats. And I could say, instead of putting this, which is a string, right? Instead of doing that, what if I said, you know, if this was actually an expression like math.vector, right? For example, maybe we would have to put a semicolon, maybe not, I don't know, right? But like, instead of being a string, this would actually be a data type, right? That would be just a regular struct that you instantiate. And this would be a struct literal, so maybe you could even fill it out, right? Like x equals 5 or whatever. The benefit of this is you get strongly typed at compile time type checking, just like you have on all your variables, right? So like you could do this, you could do them by member assignment, you could do the by value assignment. You could, of course, you could have the vector from the other thing and it's unambiguous. Now, one disadvantage to this is, well, it's probably going to be a little more verbose in the average case. I mean, for your own program, for stuff like versioning like this, what would this turn into? Well, I might just decide to name lowercase v, like within this file or within the main program, I could just say v. It's maybe irresponsible to do this for the whole main program, but I could say v is just defined as version info, right? So if I don't want to use the long name version info, I could just say v, and then I could say v.11 or whatever. You could also imagine this being function syntax, but it's a little more straightforward to imagine imagine the implementation if it's struct literal syntax. Then you could say like min equals 5, max equals 11. And then maybe I could put the other stuff in there. So like flags is no serialize or faded in editor. I don't know, like whatever you would put in here. And so this is strongly type checked. So if I typo the name of one of these, you would get that error at compile time without having to write your own compile time checker and without having to wait till runtime to see the mistake. So that's valuable. But it is a little bit more verbose. And the other thing I'm a little bit worried about is this is going to be bigger at runtime in general, right? Because like what would this version info look like? I don't know. Like let's say you were trying to make it small. So you might say min is an S16, right? So that we can go up to version 32767 or I don't know, even U16, right? And so 0 maybe means uninitialized, right? So max is a U16 and then flags is a U8. I don't know. So if this is stored packed, this is at least 5 bytes. You know, actually that's pretty small. I take it back. Because this string is 3 bytes, but it also has like a string data structure pointing at it, which like has a pointer and all that. So maybe this isn't that small, but if you're not mindful of this, if you make this like, you know, int and this int and this int, that's suddenly 24 bytes, which is, you know, maybe big. So I don't know. So that's a question. The other advantage though of this is like, this is just a struct, right? So I'm not sure how this comes into play, but any struct that you already have defined, you could use in this way as a note. So like notes wouldn't necessarily only be new things that you define. But again, I think the most valuable thing from a forward-looking standpoint is this ability to avoid namespace conflicts, which would get very confusing and messy. I think that's my biggest concern. The secondary concern is the ease of static type checking, or the benefits of static type checking. Again, I haven't thought into, this is one way to do it. There are probably alternate ways that people might have thought of, so I'm interested in hearing those. And that's probably enough to say about this right now. Let me start. I see that people have put a bunch of comments and questions into the Twitch chat. So this is going to end the official initial information dump. And we're going to go more into unstructured, just Q&A and conversation. And so if you've showed up recently to the stream, the format is we're going to do this strictly in the secret beta Discord with the beta users initially. And then after that kind of runs out, we'll open it up more generally to Twitch chat. But right now I'm not looking at Twitch chat. We're just rebroadcasting on Twitch. Hopefully, if the stream didn't go down, which I guess it didn't because beta users are watching that too. Okay, I'm not going to read through all the notes because there was a big discussion in the chat, I think, while I was talking. So I'm just going to look at the things that are added at me. So One Lives Left says making them structured would be a plus. He'd like it if it were optional. Oh, yeah. So the other thing I would say is certainly, so right now we have a big game that uses string notes, right? And a lot of beta users probably, well, every beta user using notes uses string notes. And there's two things you could do. One thing you could do is say like, well, there's string data, which is a struct, and value is a string. And every single place that you had a string note, you would have to say like string data dot whatever. That seems like kind of a pain in the butt, right? So a short version of this might just be, maybe you can just say that, right? The benefit of that is now your editor even knows it's a string if your editor isn't language sensitive, like, and knows about notes, I guess, right? So you would still have to do some conversion on your old program, but it's lighter weight and not that bad, right? And then you could have the same loosely typed notes as before, and maybe you want that. But then if you're picking that, you also know that maybe you're doing something that isn't going to scale to large programs. And maybe if you're writing a module that other people are going to use, then you know that this is a little bit irresponsible because it's easy to conflict with a program, right? But maybe we should do it anyway. And the question is like, what does that look like? Well, that's something I haven't thought too much about, but let's go to the runtime version, because I guess, again, like the compile time version, you would be able to see the syntax tree no matter what. But for the runtime version, instead of having an array of string here, it would be, I guess, an array of, let's just make a new thing called note info here. And note info would be like, it would have the type of the note. And we'll just, oh, that would be a type info. And this would be like either type info of string or a type info struct. Actually, we could just say right. So by looking at this, you could tell if it was a string or a struct, and then you would have like a void pointer for the data, I guess. And then you would cast this to the appropriate thing. Now, here's the thing, though, because I said one advantage of this is you don't have to parse the values, which you wouldn't have to parse a string, but you would still have to get the values out of a type info struct at runtime, which is a little bit non-trivial, right? Like if you've seen the print function, for example, it does that when it prints a struct. It looks at the members, it looks at the individual type, and it says, is it an integer? Is it a string? Is it a float? And then it like extracts the data and prints them. But that's not automatic, right? It has to happen. And so it's still kind of like parsing, but you're parsing well-defined binary as opposed to a string. So it's a little bit better, but it's still like, you know, it's not totally automatic. And there might be a way that you could do a higher level version of that, right? Oh, actually, okay. There's two versions of how we might implement this. I think the simplest way, and the way maybe I would prefer, is to just put the literal of the entire struct into your program. And if some of the values stay default values, they just get packed, right? So you have the entire struct. And so actually you wouldn't need to parse in that case. You could just cast this pointer to a pointer to the struct. Now, if you made the struct big, that means your executable would get big, but that's kind of your fault, right? And then you wouldn't have to parse. But what if we said, okay, what about the case where you just said min equals 5? Maybe we should only store the value of min that you said, right? To keep the data smaller. That's much more complicated. And then you would definitely have to parse it in some way that's more complicated, actually. But actually, I take it back, though. If we store the whole value, you don't have to parse. You just take the pointer. So maybe that's actually very easy and refreshing. He also says he preferred to think of a note as a proc than a struct, since that makes it easy to write a compile time thing for it. It could have multiple divergent signatures not necessarily represented in the data structure. I mean, this is a thing that is worth thinking about for sure. Like procedures in this language have overloads like in many other procedures. So I could have f of a string, right? And I could have f of x is an int, y is a float that returns vector 3, right? And you could call f and it gets disambiguated. And so if a note is a procedure, then I could say f of 3 comma 4, and we get overloading. The question is, though, this doesn't represent something that you could exactly cast to at runtime. Like this version, I really like the simplicity of the one where I could just cast this to a pointer to this type. Okay, if I statically map the type at runtime, how would I do that? I would have some code somewhere that says if info.note type is equal to type info of entity guy, right? Then I would say guy is cast entity guy, or actually, well, let's finish this first. Info.data, and then I could just dereference guy. I could say print guy name hit points is whatever, and guy.name guy.hit points. That is super easy, barely an inconvenience, right? So that's great. And you would expand this out. So like you could say, you could chain a bunch of these, right? Whatever. Or you could somehow do the runtime parsing like print does. Like if you didn't want to enumerate all these, or you couldn't know everything in advance because maybe these types come from a user library, you could still look at the type info struct and pull the members out. It's just that requires more support code and it's not as convenient, right? So that's sort of the question there. Now, if we say it's a function, this does look a little bit lighter weight right now. By the time you start dereferencing modules and stuff, it looks a less lighter weight. You don't have this period like we have for struct literals. That's a syntactic thing that might change in the long term anyway, so who knows? You do have all the same ability between structs and functions to either call with all the arguments or just say, why. Like if these both had default values, you could do this and only specify one, just like with a struct, right? The difference is if this is just a function, you kind of can't do this thing. You have to decode it somehow. And in fact, we don't give you functions at runtime, right? So we would have to like translate it into a struct anyway, which seems weird, except there is a very obvious duality between functions and structs. And so like, for example, one feature that we were thinking about putting into the language, except that you could implement it at user level. So maybe it should just be like a compile time execution macro thing, right? Either way, you could imagine saying like arguments struct of f, right? And you could imagine that generating a struct that says x int equals 7 and y float equals 42. We'll put it right at the same. And then if you were doing metaprogramming or something and you could write like a front end intercept to this function that like stores the arguments and does something else, right? And you could imagine this maybe depending on what we would want to do with it. Well, you would always also have like return struct of, right? Depending on what you want to do with this, you could, I don't know, right? We might have more back and forth between functions and structs at some point. And then maybe we could let you do either one, right? And it would just, if it saw a function here, because this is strongly typed, we know at compile time if this is a function or not. And if it sees a function, it would just do argument struct of and store that. And that might be fine. And that would give you overloading, which you don't have with structs. Anyway, let's keep moving on. Wow, that was a lot of time on that one. Ruben says, thinks the preferred way to have them would still be in the default, in the different type infos with potentially a new type info procedure argument. So you don't need to do a full metaprogram. Type info procedure argument. So that's, okay, I understand what you're saying, but that's not really how things work exactly. Because the thing is, type infos, so one of the guarantees that is made by the compiler that you use when you're programming is that if two things have pointers to the same type info, they are of the same type as far as the programming language is concerned. And if things compare with equality as a type, their type infos will compare with equality and vice versa, right? And so if we start making new intermediate types that are like, this isn't really a type, but we're using this as a data structure to hold information about a procedure argument, that starts breaking that guarantee and that duality. And it also puts more information in the executable. Now that said, we could, okay, so we could on type info procedure somehow put notes on here. But the thing is, you could have several procedures of the same type with different notes, but they need to map to the same type. So you would be like choosing one of them. The compiler would be behind the scenes choosing one of them and throwing away the notes on the other ones. And that's not good, right? So like, to be clear, I could say, I don't know, like, A is takes an X that's an int and returns an int, right? And does some stuff. And same with B, and these both have different, these both have the same types, and that matters because you want to be able to say F equals A and F equals B, or, you know, if that's on a struct, you want to be able to say that with both of these. So they have to be the same type, which means in terms of type info, you should be able to know at runtime that they're the same type. But then if we start saying like hello here and sailor here with different notes, and you're saying that that's in the type info structure, now we have to have different structures for these two things, even though they're the same type. That sounds bad to me. However, like I said, maybe we make it easier to get the syntax tree at runtime for something like this. And then it's just on the code nodes, or at compile time. And then it's just on the code nodes, but you can get them from your own program. I guess that's the question, is like, is it sufficient to have more flexibility about getting notes at compile time? Or do you really need them in more weird places at runtime is the question. Okay, so then the next thing was about string notes. Raphael says, making it simply any struct can be a note sounds clean, but it means whatever feature you add to structs will have potential damn. Now this also has to work for the notes side effects. That's true, although I would not be above introducing restrictions later, like it has to be a struct that doesn't use place or whatever. Like, I think that's okay. That's a thing that the type checker could do independently. I hadn't thought of that, but I do think if we need to add restrictions that we can. We'll see. Hopefully it can just be a literal, go into the same place as those. It could be an array of any. Oh, you mean the note info that I was doing? Where was that? Yeah, this is the same as an any. Actually, if we go into preload, what I typed is literally exactly the same thing as an any. So maybe we wouldn't introduce a new thing for this. Maybe this would be any. That's an interesting point. I'm not sure it matters too much, but it's always nice to keep things simpler. And then, I mean, well, actually it does matter, because then if you have functions that take any that you were already using for something else, you could just pass these, and those kind of functions are the kind of things that you would be doing in print or whatever, right? So maybe making this in any makes it a lot easier to use at runtime. That's a good point. Left is again saying, maybe is there two main ways to use notes, one on data for runtime, one on procs for compile time. There could be two ways to write them, the struct literal way or for the former, and a proc way for the latter. Yeah, okay, I see you were typing that probably right while I was answering the previous question and talking about it. I mean, for me, the question is not so much how you write it, but just is where is the data stored and how do you use it, and how much of a pain is that? And where does the parser have to deal with notes? And where do they go based on where it sees them? Because remember, okay, so I don't want to forget both the issues. Since we went to Q&A, I think this is natural, but I covered this in the order of where notes go and how notes are represented. And because I think this was second, that's what we ended up talking about during the Q&A, because it was the most chronologically recent thing when we did the Q&A. But remember, for the whole first 45 minutes, we talked about where can they even be and how is that represented in the runtime info, right? So that's still a big question, right? That's a little bit orthogonal to the structured versus non-structured. In favor of notes being procedures, that can be procedures that run at compile time, which needs to return a struct. So you could return a struct anyway. That's a little bit scary to me, just because compile time execution is not free. It's slower right now than it probably will be eventually, because right now we run in bytecode interpretation mode for that, and eventually we'll run in native code. So it'll get faster, but it still will always be slower than like a low-level compiler operation by a lot, right? Like invoking user-level code is not cheap. So If you have like thousands of these notes that run procedures, or if every note runs a procedure and you have 10,000 of them in a program, which is not totally unreasonable in a large program, that might impact the compile time by quite a bit. So making them that way by default, I would be worried about, but having an option where you could make a note invoke a compile time procedure, I think would be okay and probably powerful, right? I don't know how you would write that, but you know, maybe you would say like, you know, maybe you would say maybe you just say hash run whatever, right? And we would just handle that. It's just, I don't think, it's scary to me to make that the default. It's scary to me to say, if you do this, then this runs at compile time. Like that's, I'm a little worried about it. That said, though, this also introduces an interesting, if we allowed both of those, you might mean this, especially if you're new to the language, but then you might type this. And if we automatically converted that into a struct, then you would get two different things at runtime, both of which were valid at compile time. So you would still have sort of a runtime type error that wasn't caught at compile time. You know what I mean? So that's interesting. Ruben says, think them being data makes sense for the overload case. You kind of want to add, you kind of want struct overloading. Yeah, that's not going to happen in version 1 of this language. Like, procedure overloading is already such a nightmare. You guys have no idea. It sounds simple, but when you have all the other features that we have in this language too, like, oh my God, dude. Procedure overloading adds a lot of complexity. I think it's worth it. Probably, maybe, but it adds a lot of complexity, way more than it seems. So like suddenly having overloaded structs is like, oh my God, no, please. In general, them just being struct literals gives you a pretty powerful case. Yeah, I agree. I mean, like that's the thing, is there's a lot of possibilities of how to handle this, and they're all pretty powerful, and I'm just not sure which way to do it. Oh, so the other thing I should say initially is like, I know that languages like C# and whatever have like decorations, which I guess use data structures. I just ignored all that stuff when I started designing this because I wanted to do the super simple string thing. But like, you know, maybe there's something to learn from the history of that kind of thing. Like either mistakes to avoid or things that are good about it that I don't specifically know because I haven't paid that much attention to it. So one left says about where they go. Thinking if you write it as a struct literal, you bake it in as type info, whereas if it's a proc, it's a thing you use at compile time. I mean, again, I don't think that's really the problem. The problem is just, so the problem about where they go is not really about how you write the note. It's more about where do we allow you to put notes in the program, right? So like I said, this kind of thing, like if you say this, well, there's simply no way to get that at runtime right now. And maybe there shouldn't be. Maybe again, we just need to make it easier to do stuff like this. By the way, this would be a valuable experiment. This thing that I did, you can go back in the VOD later, and if this looks confusing, and restep what I was doing. If somebody wants to do the experiment to figure out how to do this without making this a code, that would be pretty cool if you could figure that out. And then we would have a concrete thing to talk about, because there might be a way to do it. It would be fun to play with. Anyway, it's more about like, where do people want to put notes? Like, okay, if I just ask the question, where do people want to put notes? The answer is everywhere, right? But the problem is like, okay, how do we make it so that you can put notes in places and it's efficient and easy to understand and doesn't overcomplicate the compiler, which most versions of this probably don't overcomplicate the compiler, but some of them might, right? And so that's the question, is like, where do they go in data that lets you do the most with them? So like if people want to scratch their heads, if beta users, so this is a hard question, both for people who are not on the beta, because you guys have just maybe seen some streams and you might vaguely recognize these data structures, but you haven't like thought about them. And even a lot of people in the beta who don't do. So, okay, so metaprogramming is super useful, and you can do a lot of metaprogramming without ever thinking about the code nodes, for example. I would bet that only at most 20% of beta testers even use those. And it's probably not even that many because it's pretty advanced, right? Probably more people than 20% use the type infos at runtime. But is it more than 50% who have a lot of experience with that? I don't know, right? And so the thing is, we kind of need people who have experience thinking about these data structures and using them, to sort of think about now that you know how these structures work, how would you use type information if it was stored in various places? Like that's a high quality kind of feedback that I would be very interested in getting, and it would be much more useful than like, hey, we want notes everywhere, right? Because I don't know what to do with that exactly. Could notes be exposed in a flat array? Yes. So definitely we mentioned that briefly earlier. I'm not sure what that would look like. That's another thing people could do an exercise in, is like, if notes were stored in a flat array, how would I use that in a program? If you wanted to write a little mock-up of how that would look, and we could, talk about that offline in the Discord or something, that could be useful. Raphael says he's strongly in favor of having notes be just data structure strings with maybe support for run. Yeah, I mean, that makes sense to me. Like support for run makes a lot of sense because it just connects you up to compile time execution, which like we know that's very powerful and great. Ruben says, to summarize what he was imagining a note to be is exactly the same as struct literal, but with an at, then you can make it a struct literal. Yeah, with also including run directives. Yeah. Ruben said he kind of tried doing something like that without the code and couldn't figure it out. Yeah. So that's another question, is like, maybe there's feature tweaks that we need to do in cases like this to let you do the anonymous struct. Like, how do I read these notes right now from within the same program? Like I said, from an external program, it's easy. From within the program, it's maybe not that easy for weird reasons that are not even good, right? So like, what is a tweak to this that would let us do that? Right. Maybe instead of the behavior of compiler get nodes seems a little bit non-obvious to me. I think the deal is it expects a code argument, right? So how do we say evaluate this thing? Okay, see, it's confusing because I changed all of this, but back when this took an anonymous type that was not a code, the question is sort of, maybe we just have a function that says, evaluate this constant and give me a code back. That would have solved the problem. That seems like a little bit of a kludge, but maybe that's fine. And maybe that's the only ingredient we need there. I think at runtime, it's good enough to have them just on type infos. You mean like we have now, or have them on every type info like people suggested? That kind of doesn't, okay. So the reason, let me go back to something that may not be obvious to people who have less experience with the language. the reason why we have notes on type info struct member, which currently they're strings, so let's put that back. The reason this makes sense, whereas I said that putting them on procedure arguments doesn't make sense, is that in the language semantics currently, every struct declaration is a different type, even if they look the same. So there's not duck typing in the base language, right? So if you make a vector 3 with x, y, and z that are floats, and someone else makes a vector 3 with x, y, and z that are floats, even if they're both called vector 3 in different modules, those are different types, and I consider that to be important for it being a strongly typed language that catches your mistakes. You can use metaprogramming to like cast those types to each other or detect that they're duck typable and cast them to each other and all that. But primitively in the language, they are different types. Because those types are unique, the members of the types are distinct from each other. And then it makes sense to put the notes on the type information, right? But that's only because structs are different types. We could do that on enums, and we just don't currently, right? Every enum is a different type, and we just didn't put the notes there because it didn't seem important. But to be consistent, we probably should put them. But something like a procedure argument, the arguments of one procedure are the same as arguments of another procedure, or actually, more importantly, a procedure that has a certain type signature is the same type as another one. And that's important because like you can't have function pointers in structs if that's not true, right? And so for that reason, it's different. That seems a little bit funny now that I say it that way, but like I think it's just the way that strongly typed languages like this work. That said, it is something that we could question a little bit. One Loves F says it'd be pretty happy if they were only available on struct declarations and struct members. Well, okay. I mean, that's what it is right now. So maybe that's okay. I don't know. I know that some other people were requesting more places to put them, but maybe when confronted with the reality of how does that work actually, maybe it's too annoying to put them other places. I don't know. Let me scroll back a minute. I skipped a couple. Maybe at compile time, you want them in more places, but then you're responsible for converting that info into runtime data if you have a runtime use case. That could be true. And in fact, maybe that's something that we provide some support code for, like in compiler module or somewhere else. We could have some kind of support code for serializing like we wouldn't want to force you to write it to a file even, but we could serialize something into an array, a constant array that gets added to your source code that you could then pass to a decoding function. And that might be very little work. Like that could be a fun thing to think about. And then the question is, where do we put it on the code nodes? I don't think I would want to put notes frickin' everywhere because again, that makes them bigger. And we already want to try to reduce the memory usage of the compiler because, oh my God, memory allocation is slow in Windows and it's not much faster in Linux. Like already a significant, like about 10% of our compiler's runtime is just getting memory from the operating system, right? That's how slow memory allocation is. Most compilers don't have that problem because most compilers are way slower, right? But once your compiler runs a little bit fast, it becomes an issue. The problem is, of course, we're aiming for 10 times faster wall clock time than we currently have in the end. Or actually, my original promise was 1 million lines per second, and we're only a factor of 4 from that right now. But we can get way more than 4, I think. So, you know, we're thinking about 10. So time spent getting memory from frickin' Windows is going to be a huge issue eventually. So we don't want to keep inflating things. Have we considered allowing notes on parameters passed to a function? We talked about that a little earlier, so maybe you came in after that discussion, but I did talk about that. You could go back in the VOD later and look at it. it is true. If you think about a print function or something, that is kind of a place that you might want to use notes. They would have to be notes that you could get to at runtime. It's an interesting point, though. You'd like to be able to at enum literals and such. I mean, maybe restricting it to struct or string is not necessary. Yeah, maybe it could be any enum. It could really, if we just have an any there, it could be any type in the whole language. I don't think that would be harder for the compiler to do. So the struct or string restriction that I talked about is, I think it's purely voluntary, and we wouldn't have to do that if people didn't want it. You'd like to tell a macro get the color scope as a code. Yeah. You actually, okay, if you have a code right now, a code data type, there is a scope invisibly stored on that. And we added in a recent beta a little bit of manipulation for that. So so when we say get code, there's this sneaky way to get the scope from another code, right? So there kind of is already this association of scopes and code right now. We could just say compiler extract scope from another code and return a code that is the scope itself. The thing that's a little scary about that is that puts restriction on how the syntax tree could look. It means scopes have to explicitly be nodes, which we might, you could imagine reasons of compactness to not do that. I don't know, but maybe that's not that big of a worry. It would be worth thinking about. I don't think we would need, so the example being given is saying I'll just paste in the example, right? So this looks kind of like let's go to a different file. This looks kind of like caller location, right? It's saying caller scope code. We could do that, but usually if you do a macro, you get a code anyway. And if you just did this, right, because you would say expand if it's a macro, you could say scope code is a compiler get scope code of code, I don't know, right? Something like that, right? So that you could then use it. You would get it at compile time and use it. If this feels a little too slow, because like I said, runs are a little slower. Maybe we would just do that. Or that. But I don't think it would have to be a thing explicitly on arguments, right? I think you could just do something. It's worth thinking about that for sure. Is there a case for runtime versus compile time note differentiation? It seems that runtime structured notes seem more useful. Compile time seems to have different forces acting upon them. I'm not sure. It's interesting to think about that. Is structure more useful at one time than the other? I'm not really sure, because if I don't want to write parsing code, then I don't want to write parsing code at compile or runtime. But if people have feedback on that, if you think that structured notes are more useful at compile time or more useful at runtime, let me know. Definitely, I think if we give you the choice of being able to just use a string or a data structure, then if you knew you wanted to use one at one time and one at the other time, you could pick the appropriate form. But it would be interesting to hear from people what they think about that. It would be helpful to get notes on type infos to be able to inspect notes at runtime for each type you put them on. I mean, I guess that's the thing. So that's the weird thing that surprised me is it's a little bit, okay. So I guess we never put notes on type info struct, which we should, because it actually makes sense to put notes on the struct because, like I said, structs have their own type. And the same for enum, right? We don't have notes on enum, and we could put them there. But putting notes on all the rest of these doesn't really make sense. Like there's only one type info integer per integer type. So like for U64, there's only one of these. So like putting a note on the type info for U64 doesn't, that seems very bad to me. So I'm not sure, like when it comes to specific type infos where it strictly makes sense, then yeah. But like putting it on this stuff doesn't make sense to me. Now that said, what I'm saying here is still strictly keeping, like this is still strictly keeping within the paradigm of the notes live in the type infos, right? You could imagine that's not how it is. You could imagine the notes is like a fully separate piece of data that isn't in these, and it's like flat, and then you get to map it at runtime or something, right? And that's inconvenient because you have to map it to use it. But then maybe that's more useful, right? So, question mark? I don't know. People could maybe mock that up and see what they think about it. So the idea to allow them to appear syntactically anywhere, again, you have to tell me how that looks in the data structures and why it's not horrible to put notes everywhere in all the data structures. Because the problem is, if you're just searching for notes, like there's a lot of different subtypes of code node. And if you're writing a meta program that wants to know what all the notes are, I mean, I guess it could just be on the base. If we could get away with just one note on the base, which maybe we could, but I don't know. Maybe that's easier for meta programs to deal with, but it's more memory. Maybe that's fine. Maybe we just eat the memory. Let me know. Let me know, people, if that makes sense to you. Putting notes syntactically anywhere. I think it might still get confusing. So like if you have a binary operator, right? X is A plus B. Like if I put a note here, I guess it would be like this. Like this is on A and this is on plus and this is on B. I mean, that's kind of gross to read. Like, honestly, that's way harder to read than X equals A plus B. Maybe your editor can collapse the notes to make it easier to read. I don't know. People can think about that and give me offline feedback. Like, we don't have to have all the feedback right now. Part of what I wanted to do is do a big info dump of what I think all the issues are, and people can think about it, and you can discuss it in the Discord later on and stuff. Like, I don't want to make snap decisions, right? I want to make well-considered deep decisions about this. Couldn't a procedure also have notes? Yes. So someone is asking this. Can't you do this? And yes, you already can do that right now, but the note does not go on the procedure type. It goes on the declaration, which you only see at compile time. So you get this note on the declaration of proc, right? We showed that earlier when we showed all the command and key map procedures, right? So that's the issue, is notes like this right now, you cannot see at runtime You can see them at compile time. But again, it can't be on the type info because again, the type info for this is the same as the type info for any other. Like, this is the problem right here. These have to have the same type info, but different notes. So you can't store the note on the type info. It doesn't make sense. That's why you can't do that. That's gross, and the chance that people know where to put it and know which ask node they need to look at to find the note is close to zero. Oh, you're talking about the A plus B thing. I agree, but that's when people say they want to put notes absolutely anywhere, that's what that means to me, right? So then if we say, well, maybe it shouldn't be absolutely anywhere, where should it be? Maybe on statements, right? Maybe it's like, instead of just on declarations, maybe you could put a note at statement level, right? And it gets attached to the previous statement. Is that good enough? I mean, that would be more versatile than what we have right now. Again, this would only be visible at compile time. Maybe that's fine. Oh, but the thing that I was saying earlier in the chat is you already sort of can do this, because if I want to put this note that says fudge, I could make a macro that's just empty, right? Called fudge. And then I could put this here. And this would actually appear as a statement inside the program. Now, it's a little bit messy because, like, if you really want this to be a note, it doesn't look like a note. And so maybe it's a little less readable for someone who's not familiar with your program. But then again, your meta program might be scanning for procedure calls anyway, and then this fits into some system you have of already scanning for procedure calls. So maybe it's fine, and maybe we don't need an additional facility. Like, maybe this doesn't have to be a note because you already can do that, right? So like, that's the question. But in the A plus B case, right, that's definitely a reason to make it a note. If you wanted to put a note here on A in the middle of an expression, you can't just put a procedure call there because you change the meaning of the code, right? So in that case, it would have to be a note. So it's a little different depending on what we want to do with it, is another point. There isn't a type info per different procedure header and body. That's correct. And again, the reason is so that you can assign those to the same variable, right? If these had different types, you couldn't assign them to the same variable, which is a thing that people want to do a lot. Well, okay. I could do something complicated that is not appealing to me right now, but we could make these different types and say they implicitly cast to some base type that is this type without notes. And that base type is like what the variable or struct pointer is. I don't really like that, because then your type infos at runtime don't really reflect the type system at compile time that people practically use. Also, you might get some surprises where you're doing polymorphism and you're accidentally creating more types of the thing that have notes when you mean the base type. I don't know. That sounds like complication. I would rather not put in the type system, but I guess that is an option if people want to think about that option. For notes everywhere, to clarify, you meant have one big single table per compilation workspace like this. In this case, what's the string? Oh, this is like if the note is a string note. So so this is like a reverse lookup. So this is like, if I know that I want things that are tagged editor command, right? Then there's just this hash table made for me that maps editor command the string to an array of things with that note. That doesn't really work with structured notes, and I think people don't always want this forward mapping, right? Like in the versioning example with the entities, if I understand what you're saying, I might be misunderstanding what you're saying, but in this thing with the entities, we don't want a forward mapping because there kind of isn't one. This is like a multidimensional quantity. We actually want to go from the member to the type. And so that concept doesn't really make sense for those. You do want a forward mapping. Sometimes that is true. I mean, maybe like if it's just a table of strings like this, you could always just iterate over the whole table and look at every string and decide what to do with it. I still think that would be a little weird. This would be more cumbersome sometimes because like at runtime, if you only had this and didn't have the current notes on the struct members, like at runtime, I actually want to know the association with specific members when I'm visiting that struct. So I would have to like rebuild all these tables from this. But then you say, well, maybe you just provide both, right? Maybe. That might be more confusing for people to understand, but maybe it's worth it, right? Maybe it's worth the complexity. Okay, I'm going to take a very short break of 1 or 2 minutes to warm, or let's say 4 minutes to warm up some tea. We will still take questions from Discord if you at me, but we're also going to start taking questions from Twitch chat in a minute or two, so people in Twitch chat can start thinking about comments from the peanut gallery. Thanks everybody for sticking around so long, by the way. There are more than 800 people viewing on Twitch right now, which is great for a discussion like this. I don't know if we got rated. Thank you if anyone rated us with people. Yes, we've been going for almost 2 hours of the actual discussion. And I'm going to take a 5-minute break, and we will come back and explore some of these issues a little more. If you guys ask me questions now, they'll probably scroll off. Twitch people, they'll scroll off and I won't see them. Discord, you can type the questions now because it doesn't scroll that fast due to much lower population. So if you're on Twitch, hold the questions off till the end of the 5 minutes when I come back. Okay, back in a bit. During the break, let me go back. I'm going to bring up the original situation. have honey lemon cough drops with soothing action for those who speak for 3 hours straight. Still a couple more minutes and then we'll start. Okay, so one live's left. We'll continue now. Someone remind me to pour the tea in a few minutes. One live's left says the idea is you keep the current system, but if someone absolutely has to put a note in the middle of a statement, they can loop over the big table and do it. Yeah, in the absolute middle of a statement, yeah. But I guess what I would like to see is what are the use cases for that? Like, even if you can't put it after the plus in A plus B, if you want to put it in the A in A plus B or something, what would that look like? So Technic Beam brought up the idea of calling print and putting formatting in notes. And to handle formatting in notes in that way, you would have to have a meta program that like grinded through those and turned those into additional data structures that got passed to the print function, probably by modifying the ast, which the way this language works, that just seems very heavyweight to me. Like modifying the syntax tree of your program, I think is not to be taken lightly because it affects compile time. It makes things slower. I mean, maybe there's a way to do it that's lighter weight than I was thinking, but we could see. The formatting in notes use case sounded reasonable, but why wouldn't you just wrap them in a normal function call? Yeah, I don't know. I mean, I do think the function call thing is a little bit verbose. So, okay, broadly speaking, I would like to improve formatting in print because there are some things, right? So right now, there are some things that in C are very easy that are more annoying here. But then there are some things we do that are way more annoying in C and that have a runtime impact. So I want to think more about print formatting generally. But for example, in C, if you want to print a float with a certain widths, right, you say printf %3.5f, right, comma value, right? And this means 3 digits before the decimal and 5 after, right? And it's a floating point. Now, the fact that the type information is in this string means, you can have errors here. There has been hard-coded type checking added to compilers or semi-hard-coded type checking that tries to check this now. So it's not as bad as it was in the earlier days of C and C++, but still this is a little bit dicey. But this is a very compact way of saying this, right? The downside is you can't really expand this formatting to things that the people who wrote the compiler didn't think about, right? Like if you wrote your own printf, you wouldn't get compiler type checking for your format string if your format string is more expressive than what the compiler format type checking knows about, right? So that's a disadvantage. But an advantage is brevity here. The way we would do this right now in a one-off case is print, percent, which has no type info, which is much more robust to errors because it gets done at runtime. But then we would say something like, I don't know, format int value, and then like what even are the arguments to format int? And we don't actually even have both of these. Oh, wait, it's a float. Sorry, format float. We actually have width and trailing width. I guess this is leading width. I should name this to be better, but it would be something like, something like that right now, which that's more verbose, right? But the thing that we do that's more powerful is like, suppose you have the opposite case where you want to print a whole bunch of numbers and the formatting is adjustable, right? In C, you then have to say like format string. Let's imagine I already made some mprintf that gives us a heap allocated string back, which doesn't even come in the C standard library, right? But you would have to be like %d dot %df, right? And then before decimal, after decimal, and then you would have to like free, let's imagine we have defer in C, which I don't even know if it's possible, but you would have to go defer free format string. And that has a performance impact. And then you would do, okay, so this is C version, just so we're being clear. You would do like printf format string value 1, 2, 3. And if you wanted to call some library that printed numbers and that library doesn't let you give it the format string, you couldn't even do it. And that's not as easy as it sounds because the library might be printing like 3 numbers. And so it would somehow have to concatenate the format string 3 times, like whatever. It starts getting really involved to try to like change the formatting dynamically in C, right? Whereas for us, we could do the following. We could just say, I'll show you this stuff. We have these default formats, right? So you could just say context.print style.default format float is, and you can call that same format float function, right? Format float, and you put a dummy value in there because that gets ignored, but say dummy to make it clear. So, and you could set whatever other formatting you want on here. And then you can just say like print whatever, comma value 1, right? You don't have to dynamically allocate a format string. And let's just say here, can't really do right. And here you just say, you just do that. And if it doesn't override your default format, then you're fine, right? So there are some things that we do that are a little less convenient like this, but then there are some things that we do that are way more convenient and powerful, right? And so I just want to be thinking about this. And so the proposal that was made before about notes, I read as addressing this kind of a thing where it's like, well, you know, it is a little more cumbersome than C right now in this simple case, which is true, right? You shouldn't, if you're making a programming language, or even if you're an enthusiastic user of a programming language, you shouldn't blindly booster your programming language and claim that it's better than everything else in all cases, right? It's like, okay, there's trade-offs, right? And so one trade-off right now is, this is inconvenient sometimes. And it's a little less readable, honestly. Oh, there's other advantages though to this, which is like your internationalization team doesn't have to worry about not screwing this up when it's in the middle of a thing that's being translated to 17 languages, by the way. Or you don't have to like worry about them desyncing, and you don't have to go scrub your string databases if you want to change this format in like 17 languages. There's all sorts of things that come into play where one is better or the other is better. And I think ours is better already for almost all cases of shipping robust, large software. That's where I'm trying to make the trade-offs. But that's not to say that we couldn't also just make this more convenient too. And so I think that note suggestion was one way of trying to make it a little more convenient. But I feel like that particular one might add too much complexity. But it's just to say I'm always on the lookout to think about how we might make this more convenient, but also keep it expandable and robust. Oh, so Raphael says, it's a good point that I hadn't really thought of, but like we could provide functions, or someone could just write C style functions. So here's the C version, right? And you could just make a function that does that makes the format float or whatever from the C value. And actually that would be a good exercise for us anyway, because we don't really support everything from printf right now in our formatting. Some things we support more of. So for example, if you're printing an int, it could be any base up to like, I think we support up to base 64, right? You could just say 64 and you get a base 64, right? So you could say base 37 if you want that. I don't know why you would do that, but you could do that, right? So there are some things we do that are much more flexible and natural than cprintf, but there are some things that we don't even support right now, right? So making sure we have complete coverage over cprintf and helping people migrate. Like if you're migrating a program from C to this language, you might groan a little bit every time you get to printfs that have a lot of this stuff and you're like, oh, now I have to think about it, right? And this would mean that people don't have to think that much about it. They could just translate it like this, and then if they wanted to reduce this to something else later, they could. I hadn't thought of that, but that's actually, that sounds good. But that also doesn't need notes, so we should probably just focus on notes so that we're not here forever. Okay. Someone says you can use star in C to declare runtime digits. I guess that's new. So let me paste the example in here. I guess that's new. That didn't used to be in C back when I learned C, I don't think. Is that new? When did that get added? But okay, so this is an example. So this is good because it means you don't have to do this dynamic malloc thing, which I have seen people do. So either people didn't know about this or the code predates this feature. So you wouldn't have to do this, but you still sort of have this problem where you can't call some other library that doesn't know about your thing, right? Okay, so let's just try to refocus on notes. I mean, we could have a printf discussion actually some other time. That would be an interesting topic. I do think this is a really good idea and we should just implement this. Maybe it's just a separate module, but like we should just do this because that's a good idea. I don't even know. I wouldn't want to do the same thing for C++. So people who do like this kind of garbage, like I don't care about that, but like this, I probably do care about. Okay, so anyone on Twitch, if you have a question about notes, or a comment about notes, how you think they would be useful to be, go ahead and @me. That way I'll see the question. Same in Discord. We're still doing questions. You just added that example to show that we don't need notes on function call parameters. Yeah, and I agree. Actually, that's a very clear example. The notes might be slightly shorter syntactically, but like not even by that much, right? Like you might not have a comma in parentheses, but like, I mean, when I start thinking about how much complexity getting the notes into data structures into the function, like what that would be, it's like, yeah, it would be it's too much machinery to do something that, as you say, you could do, just like this. But I think we should do this anyway. Like I said, this is good. We should just do that and tell people porting from C that they could do that. And make sure that we cover all those formatting features. But yes, we're back on notes. Okay, so we've got a bunch of questions coming in on Twitch. Since the struct version of the notes would already be represented as array of any, why not allow them not to be any type and not just a struct? Yeah, we covered that, and that is a possibility. The reason I said maybe only struct or string was just to keep it simple. But if it's useful, like somebody already mentioned, they want to use enums, and I think that would be fine. So maybe we should just say, hey, it could be any type. That would be fine. It's really the same. The value really comes from making it strongly typed and resilient to namespace conflicts, right? And that's true regardless of what type it could be. Would it be possible to add notes after the fact, like for an already existing struct in a third-party library? That is something that I have thought about. I'm not sure what's the best way to do that. I feel like, so there's a problem, which is the most versatile way to do it would be with something like compile time execution. Like you could run at compile time some function called add notes to this member of this struct somehow, right? The problem is that by the time you can say that, it means that that type is already available, which means if anybody looked at those notes at compile time, they probably already saw those notes maybe before you ran your thing. And so then it's like, well, maybe you could say some kind of directive that forces itself to execute first before anybody else can ever see the type of that thing. That sounds very complicated, right? Maybe there's a thing that you do in a metaprogram, like before you even add source code. Like also serializing compiles in weird ways like that is bad and is something to be avoided. Like maybe in the metaprogram, you could say, I'm making a table of like declarations and struct members that I would like you to put notes on. And when you see those, put these notes before they ever get out to anybody. That also might be a little bit slow if you use it a lot, or even if you don't. It's not obvious how to do a good version of that, but it is something that we could think about and see if we could find a good version of it. But for that reason, I haven't really done that. Could notes act like run directives, taking the expression as the first argument and other user-defined arguments, then the notes could appear in code. You could then have a struct autogen from the args for any runtime processing. I guess I don't understand why that's different from just being able to put a run directive as the value of the note. Like, what are you proposing is better about that? Have I looked at the format lib C++ library? Oh, no, that's back on the other thing. Let's not talk about printf for now. But like, I don't think the object-oriented way of things telling you how they parse or unparse, that's just not a good model for software. Sorry, it's just not. Do notes go on forever? I mean, like, depending on where we allow notes, you could have a note with some arguments that had notes on them if we allow that. It's not currently expressible with just the strings, but infinite recursion I don't think would be possible. I don't see how you would do that. What if expression @note is syntactic sugar for runtime note expr, comma, note, and then you overload runtime note for your own purposes as you want? Well, it can't. If you say it runs at runtime, the question is when at runtime does it run? And in what order? We don't currently do the C++ or even C thing where there's a bunch of stuff that runs in arbitrary order when your executable loads. We don't do that. We've stayed away from it. It actually was in for a short amount of time in this language, and I really didn't like it, so I got rid of it. And it always ends up bad when you start using that stuff, which is part of why I got rid of it. If you mean compile time instead of runtime, then that's sort of what we were saying by putting the run directive in there. But if you're saying run at runtime, that's not really helping. Like, again, a lot of the things we were talking about was like name conflict resilience. And if it's still a string, you're not really solving that problem. If you were to write an AST visualizer or something more complex that relies on the full AST, I would potentially like to add notes on arbitrary nodes to do something specific with them. Maybe, I mean, I guess I would like to see what the use case is and whether it seems important enough, because something like that, you can always accomplish something like that in multiple ways. And the question is, what ways? Let me go back and check the Discord. Seems like the Discord is quieted down. I will keep going back there once in a while to check. So people, if you want, so the Discord channel is like the priority lane at the airport, the priority check-in lane, and Twitch is like the other lane. So Twitch is like economy minus class right now. So a note is more strongly typed macro. No. It's just a different thing. I don't want to go into explaining that. You can watch some of the YouTube videos. It's just different. When doing linting house rule like things, you probably want to mark some sections of code as not conforming to certain rules. Usually that is done with comments. What do you think would be the best solution in language in this case? Parsing comments using the metaprogram, empty macros, or potentially notes. Metaprograms cannot currently see comments. Like, they don't currently get passed. People ask for that. I'm not sure I like it, but it's a thing that we could do at some point. That's another question for people, is if metaprograms can see comments, it's actually a similar question to if notes could be everywhere. If metaprograms can see comments, where do those show up in the data structures? And are they a flat array, or are they in all the nodes or whatever, right? But you could like load the file yourself from the metaprogram and look for comments if you wanted to. That just seems messy and inaccurate, but you could do that. Anyway, to get to the rest of this question, what do I think would be the best? I would probably put an empty macro right now. Or a declaration. You could always make a declaration of type void with a note on it. And then look for that. Like it wouldn't have to be a macro, but something like that. Okay, still nobody in the priority lane. All right. Very limited support for having some sort of partial types. Essentially the same logical type declaration can be split into multiple parts in source and all those get merged together. So the problem with that is, how does the compiler know when the type is done? In a programming language that has forced order of compilation, that forced order sort of tells you when the type is done. In a language like this, you don't really know. And I'm not sure how this helps, actually. One declaration could be the main declaration. The remaining ones could only repeat existing members, but additionally could add notes. I mean, I don't see how that helps any of the issues we're talking about, but maybe I'm just not understanding. Writing the proc autogen struct, you may have been bike shedding a little, as you may have thought is a nice way to collapse use cases into a single conceptual object to make it easier to reason about. I mean, I think no matter what, if we allowed a procedure syntax for notes, which is, I think that's a relatively minor issue. Syntax is always a relatively minor issue. I think the data representation that you would see, at least at runtime, would just be the struct representation. So I think you wouldn't usually have to think about it. What exactly is the difference between a note and a subtype? Like notes are not, like a type in your programming language is a thing where you declare variables of and all that. Like a note is a piece of data that is of some type. It's just like a different thing. Do you see any applications for notes in mathematical libraries? What kind of benefits does it give over normal operator overloading? This doesn't really have anything to do with operator overloading. This is more just like, okay, so for example, if I were to try to imagine how I would use notes in math operators or in functions, let's say you have some functions that do automatic differentiation on code. So like in closed form, right? So let's say I've got some function that's like a math function that computes, it does a bunch of multiplies and power functions and whatever to compute some result. And I want to, at compile time, produce the derivative of that function because I want to use that in a solver or something, right? And maybe you've got some metaprogram that looks at the code of a function and outputs the derivative. And maybe if you give it something nonsensical, it'll fail at compile time and say, you can't take the derivative of this. But like it understands plus and minus and times and pow and whatever else, right? You might once in a while want to put notes in there that are like, there's different things that you could turn this into computationally when you do the derivative and prefer this one or prefer that one. Maybe that's not a place where I have experience, so I don't totally know, but that's an idea that comes to mind. So your function that does the automatic differentiation would then look at the syntax tree for the thing, and it would look for notes like that, and it would say, oh, okay, we're going to do it this way instead of that way, or whatever. Have I looked at the attribute system of .NET? I haven't. I think I mentioned that briefly. I think I called it C# decorators or whatever, which may not be the right name. Maybe it's attributes. Wait, are decorators, is that some other language? Is that Java? I don't know. Anyway, like if people, like I'm not that, so the problem with programming languages is there's so many of them and you can look at one superficially, but you still don't really understand it. Like you don't really understand a programming language unless you've been programming in it for a couple years at least. And so it's actually not very easy to do a good job of investigating other examples from other languages, because I don't have the time to do a good job, and doing a bad job isn't necessarily that good. But if people who have experience in these languages, you could email me and make a reasoned case for why particular cases are good. You can email this email address and just let me know, like, hey, .NET, attributes are good because of the following thing. And if you sound like you know what you're talking about, then I will pay attention and think about it. The problem on the internet is, like anything, most people, like the percentage of people who are really good is a minority, right? And so often when you put an email address in a video, a lot of what you get is low quality responses. But if you have high quality responses, feel free to respond to this video with your high quality information. Still, I guess maybe all the first class passengers got on the plane. I don't know. That was regarding the ability to find notes on someone else's code. Oh, the incomplete structs thing. Yeah, I see what you mean with that now. I see why that addresses the problem, but it's something that doesn't seem super great. But maybe it's something where we could just have very loose guarantees around it, and that's fine. Like maybe look, if you use this directive to put notes on something, then they're guaranteed to be there at runtime. You don't know when they appear at compile time, and don't necessarily expect to see them if you're looking for them at compile time, right? Or like you could do a funky thing where there's ways of like synchronizing your function to that so that it won't run until after, that are currently just weird hacks that nobody knows about. But you could do something like that. So maybe I would, here's what I would say is there's sort of several levels of depth at which we could solve this problem. And I would like to solve the problem for code that you're in control of first, and then sort of look at this issue of like, how do you put notes on somebody else's module when you don't want to modify the source code and stuff? Because I think there are a variety of ways to think about doing that, and it feels orthogonal to me. Like that feels orthogonal to whether notes could be structured, and kind of orthogonal to where they can live. Maybe not. What is the problem with functions with notes having the same type but different notes? Type info could just ignore notes for compiler type checking and let the user care. Because there's only one type info per type. That's the point. And because you want to know that. Like if you take the type info of two things and compare them in your program at runtime, you want to be able to do that comparison and know what it means. And if we start clouding that by saying, well, there's many type infos for one type, it reduces the certainty around that kind of operation. Which, even if you're not explicitly using that certainty, you're probably implicitly using it. Now, that said, that's not something that I am 100% clear is the right answer. But I'm 80% clear that that's the right answer, is that we shouldn't cloud that by adding more types. Like, it just feels wrong to add more types just to have places to put notes. Like, I would rather put notes somewhere else than do that. Re-subtypes versus notes. The initial type is defining the variable's value, and the note is giving meta info on that object, which you could later hook into to modify that value. Is it not the same as modifying the initial type with the node at compile time? No, it's not the same, because the question is, are two variables the same type or different types? If you make the type parameterized and you say they have different parameters, then they're different types. If there's just notes on them, then they're the same type, but they have different notes on them. And whether things are the same type or not, you can say, oh, that doesn't matter. It's all the same somewhere in cloud cuckoo land. But like in a strongly typed compiled programming language, the job of the compiler is to check types. Like that's most of what it does. So like you're talking about how things look to the compiler's primary job that it's trying to do. Okay. Oh, we have people in the first class. Was it discussed whether notes could exist? Oh, these aren't added at me, so I don't know if they're to me. Let me see. Yeah, we did discuss whether notes could exist as a standalone statement in a procedure, and we said that's the same as an empty macro. And so it's not clear whether that's that useful. Like you can already sort of do that already with an empty macro is what we said. And so like maybe there's a small benefit to be gained in terms of like conceptual cleanliness by making that notes, but it's not, it doesn't really matter in terms of what you were able to do today, right? Like the part that matters is if you say you want to be able to put notes on sub expressions, you can't really, like an empty macro call is like a procedure call, right? So you can't like put that on a sub expression of your program without changing the expression, right? And so, I mean, I guess it could be a macro that return. Oh God, this is stupid and ugly, but like in this A plus B case, right? You could say X : equals note macro A hello plus B, right? And then like note macro is like I mean, I guess that would work. That is really disgusting. Both in readability here and here, but like you could do that today, I guess. So I don't know. Maybe somebody should try that and see how it goes. Someone says, in my experience, decorators' attributes are mostly but not exclusively useful for library developers to allow users of the library to do something complex, optionally magically, like marking a struct or struct members for use in an ORM or whatever. Yeah, well, I mean, that's exactly what the existing notes that we already have could be used for as well. So if that's the main use case, we kind of have that covered. But it sounded like the Twitch person was suggesting that other use cases, well, no, the Twitch person was just saying they're pretty good. I don't know what that means, right? So we'll see. All right, back to Twitch chat. How would you be able to use that as a note on the plus? You would do this. You just you would put the A plus B on the inside. Oh, although, okay, no, this is really gross because if you want to, this would give you the resulting value. So like maybe you would do this and dude, I don't even know. Like I'm getting hives thinking about this, but Like if you wanted the actual syntax tree of a plus b to do something with, you could do that. I guess you would pass the note. I don't know. Types look like very specific notes. That's why you're in economy minus. Sorry. No, I mean it's hard. Like people who are really used to using the programming language, like kind of know by feel the difference between these things. And when you don't have that experience, it's like sure things look the same or whatever, but like they're really not. Because like I said, this is a statically type checked programming language, so types are a big deal in a statically type checked programming language. They're a specific thing, you know. They're not just like a random, like if you look syntactically at how they are, that's not really what they are. They're a thing that comes into play everywhere. If a note does something after initial labeling, what's it doing that's not just adding more type info? Well, we covered that. I mean, there's two ways. It could be on the type information. It could be on the syntax tree that's browsed by your metaprogram. If you missed that part, you could watch the earlier part of the stream. Notes don't do anything by themselves. They are things that your metaprogram could look for or that your runtime program could look for, right? So thinking about notes as actually doing something might cloud the issue a little bit. What really it is that other code looks for them and decides what to do based on what it sees. The use cases for C# attributes staff devs deal with usually in Unity has to do with serialization and altering the generated editor UI for structs members. Okay, I mean, that's exactly the use case that we already do all the time in the Sokoban game, and that all this is fine for. So like, we sort of have already solved that for our own purposes before you get into anything that we talk about today. The only question being, like I said, as you get larger and larger as a program and interact with more modules that might have their own meanings for notes, it's a good idea to have structured notes to disambiguate these. But apart from that issue, we've got those use cases covered. May make sense to call these tags instead of notes. Sure. I mean, depending on what they end up feeling like and what kind of data ends up being in them is, I'm a big believer in naming being important. So depending on how they end up and how they end up being used, we could change the name for sure. Like notes is just, I didn't know what to call it. And I was like, what is it? Okay, notes. But like that could change. Extra data that you can embed in the attributes is also useful. Yes, but you already could do that either here or in the structured version. So I'm not sure what the difference is. I might be missing something again because I'm not that familiar with those languages. Unclear when star was added. Oh, this came up a while back. Okay. So star is maybe in some printfs, but maybe not all of them. Maybe it's not in the standard, who knows? I'm sure we could look that up after the talk. Would something like macro decorators for last nodes work? Uh-oh. Someone is putting BNF in their frickin' thing. The question is not the syntax. The question is, where does the data go and how easy is that to deal with, right? We're worried about, like, when you're writing a meta program that wants to know about notes, how easy or hard is it for you to do what you want to do? The attributes in C# are used to be specified, for example, data type when you want to have a string that can be printed. Yeah, we don't really do that right now. We don't encourage that. You could do that, but again, part of what I'm trying to do is reject this object-oriented idea that objects tell you how to print them. I don't think that's good. I mean, you can come up with some simple use cases where you maybe want that, but they fall apart very quickly. It's not good. Like, you want to give people flexibility over how to do things, right? You could say, well, that's just advice about how to print things. And if you had structured notes, then we could maybe do that. You could do, like, you know, format float of 3.5 or whatever we were talking about, right? Like, it's just, it feels wrong to me to encourage that, because when you make a data structure, it's a general thing that many people may look at, and you don't know how they're going to use the data structure, right? You don't know what they care about. So, I don't know. It just seems wrong to me. That said, maybe it's something we could do, but our standard print function does not do that currently. It does not decide how to print things based on notes on the struct. We did originally have a thing, maybe it's still in there. We had a thing where you could statically define a print function on your struct, but, like, the more time goes on, the more I don't like that. Yeah, I think I took that out. There were, like, print me functions or something. I think that's not currently a thing. In a game loop, that's off topic. We're talking about notes, although the discussion may be coming to an end soon, I think. Okay, well, so that's, we did a lot of communication today. I think we're running out of questions. If anyone has any last minute high quality questions, get them in now. We have print like and scan like. Yes, but that's for argument checking and not necessarily how to print things. Although, print like and scan like do. Actually, scan like is not something that I wrote, and so I may not be happy with it. It may violate, because scan like is a little more like C style scanf, and I kind of don't think I like that. But if I were to write a scanf from scratch, it might not look like that at all. So I'm not sure about that. But the print like is sort of, it just sort of checks the number of arguments and stuff like that, right? It doesn't check formatting of the individual arguments. Have I thought about giving each token a unique identifier and have an easy way to map a token to code nodes? I mean, isn't that what already happens? Both notes and comments can be stored with the token. I mean, you would have to give me a very specific example of what that looks like and how it would work for me to evaluate that idea. for the star in printf, it's first described in the C18 standard. Okay, so it's pretty new. Pretty new. Although some individual implementations might have done it a long time ago, right? Okay. Anyway. So we did a lot of discussion. For people in the beta, I am very interested in, if you want to like mock up how things would look for ideas that you have, either in terms of user code, like how it would look in a metaprogram or in runtime, or in terms of the data structures, how it would look, and just let me know, because I think that's the hard part, is like having some experience in the language and then looking at what that turns into. I'm not looking necessarily to work on this like right away. We're not having this discussion to like ship this next beta. This is something that we're just going to think about for a little bit and decide what to do with. But it's something that, you know, it's been on the list for a while to do the better version. And I just want to make sure we do a good, better version of it. Now that we're hitting 3 hours of the stream, it might be time to sign off. So yes, I'm interested in hearing from people. Please send high quality ideas to the email address. And thank you for hanging out. We've still got 769 people, which is an amazing number of people. We could raid somewhere to send all these people. Is Casey still going? Let's see. Yes. Okay. So we're gonna send you over to another Twitch channel. Thank you for coming by. We'll do more streams sometime soon, and of course we'll do more compiler work and all this stuff sometime soon. So thank you, everybody. And I'll see you later.